Second International Physics Olympiad, year 1968, IPHO. Problem number 1. On an inclined plane of 30 degrees, a block mass M2 equal 4 kg is joined by a light cord to a solid cylinder. Mass M1 equal 8 kg, radius r equal 5 cm. Find the acceleration of the bodies are released. The coefficient of friction between the block and the inclined plane μ equal 0.2. Friction at the bearing and the rolling friction are negligible. Solution for problem number 1. First, let's draw the free body diagram. So in this diagram we have forces acting on this cylinder and the block. If the cord is stressed, the cylinder and the block are moving with the same acceleration a. Let F be the tension in the cord, S the frictional force between the cylinder and the inclined plane. The angular acceleration of the cylinder is a over r, because there are no sliding. The net force causing the acceleration of the block is this one. M2a equal M2g sine alpha plus force F and minus force of friction, which is mu M2g cosine alpha. And the net force causing the acceleration of the cylinder is this one. The equation of motion for the rotation of cylinder is I beta equal SR, where I is moment of inertia for cylinder, which is 1/2 m1 r square. Beta is angular acceleration, which is a over r, and the S is force of friction for the cylinder. So from this equation, putting this expression, we have 1/2 m1a equal force S. And now we can put this expression for S to the second equation, and we have this one. Now we have first equation and this equation, and we can exclude force F, just adding these two equations. Finally, solving all these three equations, this, and this, we can find that acceleration equal this expression, which is about 3.25 meters per second square. Force S equal this expression, which is about 13.01 Newton, and the stretching force between block and cylinder is this one, which is about 0.192 newtons, which is very small, but it's still positive. Now let's investigate what happened in critical positions. For the system start to move, we have acceleration must be greater than 0, and from this formula we have tangent alpha equal this expression, which is 0.0667, and the critical angle is 3.81 degrees. For cylinder to move, we just have angle alpha must be greater than 0, and for block separately to move, we have tangent alpha must be greater than mu. It means that alpha is 11.31 degrees. Tangent alpha greater than mu, and the critical angle is 11.31 degrees. If the cord is not stretched, both bodies move separately, and the critical angle for that when F equal 0. It means that tangent alpha equal 3 mu or 0.6, and the critical angle is 30.96 degrees, which is slightly greater than our original angle 30 degrees. So, and after this critical angle, they will move separately. basically we finished discussion for problem number 1. So we found what is acceleration. That was 3.25 meters per second square. We found that force F is a stretching force. It means that both bodies move together, and our angle slightly less than critical angle for which these bodies move separately. So that was solution for problem number 1.